So today, guys, we're going to learn how to use intercepts. So the essential question that we're dealing with is how can you identify and use intercepts in linear relationships? So we've kind of been already doing this in 5.1, so it's not going to be anything too crazy different. Actually, I hope you guys will find it a lot easier. So the first step is let's identify what the x-intercept is. And again, we've already talked about this, so hopefully, again, it's familiar. But the x-intercept is just where a line crosses the x-axis. I have a quick graph. There. Then the x-intercept is going to be this point right there, because that's where it crosses the x-axis. Let me put that in green so you can see it. Okay, so it's the x-intercept. And the x-intercept is always written as a point. It's written as the point x value, and then your y value is 0. So when you graph it, it's when y is 0. The y-intercept is where it crosses the y-axis. Okay, and again, if I draw that graph, and the y-intercept is where it crosses the y-axis, which in this case would be right there, and that is the point that has 0. Sorry, yeah, 0 y. Let's see. Okay, so that's how just identifying the x-intercept and the y-intercept. So right now what we're going to do is we're going to find the x-intercept when we're given an equation. And how you do that is you replace the y of 0 and then solve for x. So notice that if I replace y for 0 in 3x minus 2y equals 6, then I'm just going to have 0. So really, I can just reduce it to 3x equals 6, because again, when I replace y with 0, I'm going to have just 0 there, so 3x minus 0, which doesn't do anything. So 3x equals 6, you divide by 3, x equals, x is equal to 2. So it's that easy. So 6 divided by 3 is 2. So since x equals equal to 2, then the intercept, remember, has to be of this form. So the x-intercept would be the point 2, 0. Over here, it's the same thing, but this time I'm replacing x with 0. So again, same deal. If I replace x with 0, then it becomes 0 minus 2y, which is just negative 2y. So I can just go ahead and skip down to negative 2y equals 6. And again, just solving for y, I'm going to divide. And when I divide by negative 2, I get y is equal to negative 3. That's my y-intercept. So when I go to write my y-intercept as a point, it's going to be the point 0, negative 3. So remember, for the y-intercept, you're going to have a value in the y place, and for the x-intercept, you're going to have a value in the x place. That's how you can remember it. So on this next one, we're going to just find the intercepts of negative 5x plus 6y equals 60. I encourage you to pause the videos and see if you can solve it on your own. And if you can't, then you can just stay along with me. So pause the video, try to find the x-intercept and y-intercept, and then come back. All right, so if you pause the video, then you have the x-intercept and the y-intercept. So what you should have done is you should have just started out as negative 5x equals 60. So what I'm going to have is negative 5x equals 60. Divide by negative 5. X is equal to, x is equal to negative 12. Means my solution is going to be the point negative 12. Yeah, that's my x-intercept. So hopefully that's what you got. If you didn't, try to see where you maybe went wrong. I'm going to box out because that's actually the answer, remember. The y-intercept, we're doing the same thing, but this time we're setting 6y equal to 60. I gotta use the right tool. And then when I divide by 6, I get y is equal to 10. So then, pretty easy. My y-intercept is the point 0. And that's really all there is to finding the intercept. It's not that bad. What's nice is when you get it broken down, it's really just solving a bunch of one-step equations, which is, again, really easy. So the reason why we use intercept form is because when you're given an equation in standard form, it's a pain in the butt to kind of rearrange and solve. Because you have to solve, like, do a multi-step equation. But when you have the intercepts, it's just really moving one variable and graphing. So in this equation, I have 18y equals 12x plus 108. So remember, in order to have it in intercept form, it needs to be ax plus by equals a number. So I have the y over here. So really, I'm going to do is move that x over. So I remember to move it, I just do the opposite. So I'm going to subtract 12x from both sides. And when I subtract, I'm going to have negative 12x plus 18y equals 108. And then this is the equation that I can find the intercepts for. So that's what I'm going to do is I'm going to start by finding the x-intercept. The x-intercept is going to be negative 12x equals 108. Divide by negative 12. X is going to equal negative 9. Which means that my x-intercept is at the point negative 9, 0. I'm going to do the same thing for the y-intercept. And again, I'm just taking the y part of the equation. So 18y equals 108. I divide by 18. Oh, can you get something? Hey, Julia, can I see that really quick? Sorry, guys, my brain's not really working today. I think it's 6, but I just want to double check. Oh my gosh. Yeah, 6. Yeah, it's just not feeling myself. So y is equal to 6, and then my y-intercept is going to be at the point 0, 6. All right, so then now I have my 2 points that I can graph. So the x-intercept, I'm graphing on the x-axis at negative 9, 0, which doesn't fit, but it's going to be all the way over here. And then the x-intercept is at 0, 6. Sorry, the y-intercept is at 0, 6, which is right there. So I have a point on the x-axis, I have a point on the y-axis. Last step is just to connect the dots. Oops, then that is not the right tool. Now we're going to connect the dots. So your graph should end up looking like this. Obviously, you'd want it to fit on the graph, but in this case, it wouldn't. So that's what your line should look like. Now I wanted to do something with fractions, because fractions just make us poop our pants. So let's try this out. So same thing, I need to rearrange the equation, so I'm going to just add 3/4 x over. And when I do that, I get 3 over 4 x plus 1 over 2 y equals, so all I did was move the 3/4 x over, so when I did that, I just changed the sign. All right, now that I got that, I'm going to go ahead and find the x-intercept. Remember, in this case, this is where I'm taking the x piece and setting it equal to 0. So I got 3 over 4 x equals 3. Now, to get rid of the fraction, I'm actually going to multiply by 4 first. So when I do that, I'm going to get 3x equals 4 times 3 is 12. Okay? And again, I just multiplied by 4 to get rid of the fraction part. And then now I can divide by 3. So x is equal to 4. Which means my x-intercept is going to be at the point 4, 0. I'm going to do the y-intercept. Same deal, but this time setting the y piece equal to the 3. What we had 1/2 y equals 3. Now to get rid of the fraction, I just have to multiply by 2. And when I do that, I get 1y, which is just y, right? So I'm actually going to have y is equal to 6. So even though it's a fraction, it actually wasn't that bad. Just remember you have to do the opposite. So if I'm trying to get rid of the bottom of the fraction, I got to multiply. So y is equal to 6, which means my y-intercept is at the point 0. Oops, not g, 6. And just like last time, I'm going to graph these points. So I'm going to have a point at 4, 0, which is right here, point at 0, 6, which is right there, and then connect the dots. And there we go. So that's how you graph linear equations. So on this one, we got a word problem, and we're going to find the intercepts in a word problem, and then we're going to interpret what they mean. So in this example, the Sandia Peak tramway travels 4,500 meters to the top of the Sandia Peak at 300 miles per minute. And this time they give us the function. They give us this f of x equals 45, should probably do it correctly, 4,500 minus 300x. So this function is actually describing the distance the tram is from the peak, which is what it says. And x represents minutes. So if I find the x-intercept, we're going to try to identify what it is that I'm finding. So if I plug 0 in for x, what do I find? Well, I'm going to have, remember f of x and y are the same thing. So when I set this up, I'm just going to write it as negative 300x. Actually, I'll make it positive. All right, because remember, I'm going to add that 300x over. So 300x plus y equals 4,500. If I find the x-intercept, what does that mean? Well, I'm setting 300x equal to 4,500. And when I divide these, oh gosh, I'm going to get 15. So x is equal to 15. So what does 15 mean? Remember, 15 is the x-intercept. So if I thought about this as a graph, then 15 is over here. Switch, remember 15 is time. And so if it's time, and then f of x represents distance from peak, so height, then 15, at 15 seconds, that would represent where the tram started, right? When the height is 0. Am I doing this correct? Travels 4,500 meters to the top. So when x is 0, it means that that's where it's starting at. Notice I didn't have to give it as a coordinate this time. That makes it a little bit easier. So the tram takes 15 minutes to reach the top. Because remember, if it's 15 minutes away and it's on the ground, then that means that it should take it only 15 minutes to reach the top. So that's what we just explored. So now I got to find the y-intercept doing the same thing. But this one is just, if I said get rid of the 300x, and I just have y equals 4,500. It's pretty easy. And what does 4,500 represent in this equation? Well, 4,500 represents the top of the peak. So that's where they're going. So it's the top of the peak. That's all you got to write. Of the peak is 4,500 meters. Easy. And there you go. And that's it for notes today. So hopefully this makes sense. You can go ahead and start working on your assignment. Hopefully I'll see you guys soon.